All right, you guys, so today we're going to focus on doing the opposite of what we did last week. So last week I gave you a vector like 2i plus 3j, and you found me the magnitude and the direction. Today I'm going to give you the magnitude and the direction, and you're going to find me A and B, okay? So our first diagram that I'm going to draw is just kind of the relationship between all those things that I just talked about. So just somewhere in the first quadrant, I want you guys to draw a vector, call it V. Okay, and then draw dotted line straight down and straight over. Okay, so using vector language, remember this is I and this is j. This would be the magnitude of the vector. This would be the A component, and this would be the B component. Okay, the direction would be this angle right here. Okay, measured from the positive x-axis. Okay. So again, if I give you this and this, you'd use Pythagorean theorem to find that, and you'd use tangent to find that. Okay, so this is what we've been doing, since January in this class is this. If you had a unit circle, okay, so this was 1, okay, this was theta, then you would say this is the cosine and this is the sine. Okay, we all know that. Okay. Now the thing is vectors are a little bit different because the vector, in order for this to be true about a vector, it would have to have a magnitude of 1, which it can have, but it almost never does. But the idea is really similar. So if I made this 2 instead, okay, then the cosine would be twice as big and the sine would be twice as big, okay? If I made this 4, then the cosine would be 4 times as big and the sine would be 4 times as big also. So everything's proportional, okay? So using that idea right here, the A value isn't just simply the cosine of the angle, because that would only work if this magnitude was 1. If this, whatever this magnitude is, you have to multiply that by cosine theta to get that value, okay? Similarly here, if the magnitude was just 1, that would be sine theta. But if the magnitude's different, you just multiply by the magnitude, okay? So what that means is that the A value always equals the magnitude times the cosine, and the B value always equals the magnitude times the sine, okay? When we write a vector, we write it in this form. Okay, so now I can just simply replace that A and B with what we just discovered. So when you write a vector, you're going to say it's the magnitude of the vector multiplied the cosine of theta is the I component. The magnitude of the vector multiplied by the sine of the angle is the J component. Okay. The important thing to know, this is really important actually, is that theta always is measured from the positive x-axis. Okay. So it has to be measured from here going that direction, okay? Measure from the positive x-axis, right? Okay? All right, so let's do a couple of examples. Okay, the most straightforward thing that can happen is I can just give you the information you need. So in the first problem, I'm going to give you exactly what you need. I'm going to tell you that the magnitude is 50 and the direction is 135. The book uses this symbol, which is the alpha. It's the Greek letter A in the, it's called alpha. They use that. When they use this, it means direction. So they're telling you that the direction is 135. Remember, direction is always measured from the positive x-axis, so this is this angle right here. This is 135. Okay, it's kind of nice to draw it because if you do draw it, we know that we're trying to find the A and B components, right? We know that the A component is negative, the B component is positive. It's a quadrant 2 vector, okay? So the formula says it's the magnitude of the vector multiplied by the cosine of the angle is the I component. The magnitude of the vector multiplied by the sine of the angle is the J component. It's as simple as that, okay? Now, if it's a unit circle angle, like 135, right, that's the same as 3 pi over 4, I don't want you to use a calculator. So this would be root 2 over 2, negative, because cosine is negative in quadrant 2, and the positive for sine, because the height is positive in quadrant 2. So the answer to this problem is if you go negative 25 root 2 in the I direction, positive 25 root 2 in the j direction, that gives you the components of your vector, okay? So that means that this is negative 25 root 2 and this is positive 25 root 2, okay? All right. Let's see, I guess I can probably just spit it in here. Problem number 2, okay? I'm gonna give you that the magnitude is 6, and I'm gonna give you a bearing of south 60 west. Okay, so one of the most common mistakes is that people just assume that 60 degrees is the theta angle in this formula, but it's definitely not. So if you have a bearing, you're gonna wanna draw it out. Southwest means you go down and west 60 degrees. So this is 60, this is 30, okay? The direction, this is really important, is measured from the positive x-axis all the way around till you get to the vector, okay? So the theta in this problem is 180 to here, plus another 30, so it's 210, okay? So if I give you a bearing, you have to adjust it to become a direction, okay? So 210 degrees is a quadrant 3 vector, which represents south 60 west, okay? All right, and then to get the answer, you say the vector, let's call this one W. Vector W is the magnitude times the cosine of the direction is the I component. Magnitude times the sine of the direction is the J component, okay? This again is on the unit circle. 210 degrees is the same as 7 pi over 6. Both sine and cosine are negative there. Cosine is negative root 3 over 2, and sine is negative 1/2. Okay, whoops, I added a 0 there. Okay, so this vector has a component of negative 3 root 3 and a j component of negative 3. Okay, which means that you go negative root 3 in the a direction, down 3, and you'll get that vector. Okay, so now we're going to move on to ones that require a calculator. So if you don't have a calculator, just pause this and go ahead and grab yourself one. Okay. Okay, so problem 3 is vector u is a magnitude of 200. And a direction of 100 degrees. Okay. All right, so this one is, it's not super hard. It's lovely because I gave you the direction, which is what you need. The only difference is, so it's magnitude, cosine, direction, I, plus magnitude, sine, direction, j. The only difference in this problem is 100 degrees is not one of those angles that you can do without a calculator. But you should know what quadrant this is in. 100 degrees is right here. And you should also now know that the A is going to be negative, the B is going to be positive. And just looking at your picture, the B should be much bigger than the A. So you can also use that to kind of help figure out if you did it right. When you do it in your calculator, this is a degree measure, so make sure your calculator's in degree mode and just simply type in 200 cosine of 100. Okay, round it to the thousands, so negative 34.730 is the I, and then do 200 sine 100, and you get 196.962 is the J. Okay, and again, those numbers do match what I thought would happen using my picture. Okay, all right, we're gonna do one more example. Okay, in this one, I'm just gonna draw you a picture. I want you guys to draw me this picture right here. This is 10 degrees, and this is 50 magnitude. Okay, so the length is 50, that's 10 degrees, okay? Not super hard. I just want you to get used to all the little different formats. Okay, so in this problem, the magnitude of the vector, we'll call it B, is 50. So you need to know magnitude and you have to know direction. So the direction, theta, okay, is definitely not 10, okay? So you have to be careful about this, remember. And we're gonna start doing word problems with this. This is where this will be really important. You are gonna start here and you're gonna go, oh, this pen doesn't work, hold on. I don't know why I keep it there. The direction is you're gonna start here and you have to go all the way around to here. We all know that it's 270 to here, so that makes the direction 280, okay? All right, and then once you have all that figured out, again, you just type it in. So vector equals 50 cosine 280 is the I component, and 50 sine 280 is the J component. Again, 280 is not one of those things that you know without a calculator, so you type in 50 cosine 280, and you get 8.682 in the I direction, and 50 sine 280 is negative 49.240 in the J direction. And then again, I would just say, look at your picture. Does it make sense that you go over 8 and down 49? Yeah, it does make sense, okay? All right, you guys, so that's it for today. Just email me if you have any questions. Okay, bye.